Hello everyone. So today we will be discussing about our eighth lab program that is on doubly linked list. So before starting the implementation, let us understand what are the operations to be performed. So this eighth lab program is on doubly linked list and performing some of the operations on employee data for the given fields. Okay, so this is to design, develop, and implement a menu-driven program in C. Similarly, like the previous programs, we are using menu-driven program here using switch case. So for some of the operations on doubly linked list. Okay, so we are implementing doubly linked list concept here for the employee data. Okay, and I have mentioned what are the fields to be considered for employee data. So the fields are SSN, name, department, designation, salary, and phone number. So these are the data fields to be considered while creating the doubly linked list and also to perform some of the operations given. So let us see what are all the operations to be performed. So the first operation here is to create a doubly linked list for n number of employees by using end insertion method. So as already we know that insertion, we have different types like insertion from the front, insertion at the given position, and insertion at the end. So here the first operation is to create a doubly linked list for n number of employees. So n can be any value given by the user. So depending on the value of n, so we have to use end insertion concept for creating the nodes in doubly linked list. That is the first operation. Second operation is to display the status of doubly linked list. That is to display the contents of each of the nodes. So it will be starting from the first node till the last node. You have to display the data part which is present in individual nodes. So that the data part in this example will be the employee data. And also you need to count the number of nodes present in the linked list. So number of nodes will give you the details of how many employees are present, because for each node you will be storing the employee data. That is the second operation, to display the contents of each of the node and also the count present in the linked list. That is the total number of employees. So third operation is to perform insertion and deletion at the end of doubly linked list. So that is the concept of end insertion. And fourth operation is to perform insertion and deletion at the front of doubly linked list. Okay, so normally we know that insertion and deletion can be done from different ways. So here in this example, we are third and fourth operation, we are considering insertion at the end and insertion and also deletion at the front and end cases. And the fifth operation is to demonstrate how doubly linked list can be used as double-ended queue. So double-ended queue, already you know what is the difference between double-ended queue and the normal queue. Double-ended queues are the queues where insertion and deletion can be performed using any of the ends. Okay, normally when you consider a normal queue, front will be used for deletion whereas rear was used for insertion. But here double-ended queue is a method where any of the ends, whether it is front or rear, any of the ends can be used for both insertion and deletion concept. So fifth operation is only to demonstrate the doubly linked list concept as a double-ended queue. So there is no additional implementation here. So we are using the operations from third and fourth to demonstrate how it can be implemented as a, how it can be done for the double-ended queue. That is the fifth operation. And last case is, as you already know, a menu, there should be an exit case. That is the exit case. So these are the five operations we need to perform using the doubly linked list concept for employee data. So before starting the implementation, let us understand the concept first. Okay. So, as you already know, singly linked list, you will be having a collection of nodes where each node will be having data part and link part. So, what is the difference between singly linked list and doubly linked list is when you consider the node structure of doubly linked list, along with the data part, we will be having two link part indicated here. Okay, you can see in this example, there is a left link. So this left link is a pointer which will be pointing to the previous node, and another link is a right link which will be pointing to the next node in the linked list. Okay, so it can be considered as left link or right link. Left link can also be considered as previous link. Some of the cases we will define the variable as a previous link. So previous and left link both are same. So right link can also be indicated as a variable called next. So some of the convention we use previous or next, or sometimes it can also be considered as left link and the right link. Okay, so hence it will be having two link parts, that is for every node we will be having left link and the right link. And what is the advantage of this doubly linked list compared to singly linked list is, so you can easily access any of the nodes because we also have a previous pointer. Okay, and also normally like singly linked list we have a next pointer so that accessing the elements become easy, whether it is insertion or deletion, that will also be easy compared to your singly linked list concept. In singly linked list, we were having only single pointer that will be pointing to the next node. So that is the advantage. So this is the node structure. Node structure of doubly linked list with data part and two link parts. According to the question, they have considered the employee data here. Okay, so hence the data part of every node in this program will be having the details related to employee, that is already specified in the question itself. So the data part will be having SSN, name, department, designation, salary and phone number. So we have six elements in the data part. Okay, so normally when you consider single data, it will be having only one of the value, but here it will be having six data elements. Okay, along with that, it will be having the left link and the right link. Okay, so this second diagram you can see we have two nodes here. So to differentiate how it will be linked, so the right link of first node will be pointing to the next node, whereas left link of the second node will be pointing back to its previous node. Okay, so when you look at this diagram, you can see there are four nodes. The data indicated in the four nodes are character type, that is A, B, C, D. Okay, so every node you can see there is a next link and also the previous link that will be pointing to the next node and the previous node. When you look at the first node, so there the first node should also have the left link, but since that node itself is the first node, the left link of that particular node will be having the null value. Okay, so always the first node, when you consider the first node, its left link will be always equal to null because that is your first node. You don't have any node before that particular node. Okay, and also there will be a header variable or a header node, or it can also be first pointer or a first variable which will be pointing to the first node. To differentiate, to fetch the address of the first node, we will be using a header variable. And finally, when you go with the last node, similarly like singly linked list, the last node will be identified by having the null in its ring part. But here, when you consider the doubly linked list, the right link part of the last node will be having the value equal to null. Okay, so this is the concept of doubly linked list where the data part will be depending on the given application. According to our example, it should be having six data elements and indicating all the previous and the next links. Okay, so with this data, with this node structure, now let us understand what are the operations to be performed. So we now understood what is the data part and also what is the node structure for doubly linked list. So now what is the first operation? First operation is to create the doubly linked list for n number of employees by using AND insertion. Okay, along with that, we should also check how do we perform insertion and deletion at the front and also at the end location. Okay, so generally to describe, I'll just take two nodes. Okay, so where every node should have the data part in the left link and right link. Okay, so just for an example, I'm considering two nodes. Okay, so the data part of employee field contains six different elements, but as of now, just for understanding, I'll just consider the SSN of an employee. That is, SSN is the social security number. So it is an identification, unique identification given for each of the employees. Similarly, like USN given for each of the students, which is unique. Now I'll consider SSN of an employee. It is equal to 1 and second employee it is equal to 2. Okay. So when you consider doubly linked list, the right link of the first node should point to the next node, and what happens to the left link of second, it will be pointing back to the first node. Okay. As of now, we have two nodes indicating the employees, two employees are present. Okay, and also you know that there will be a pointer, either it will be a header node or it will be a pointer called first, which will be always pointing to the first node in the linked list. Okay, so to differentiate what is our first node, it will hold the address of first node. Okay, so to consider the first node, what happens to the left link of first node? It will be equal to null because that itself is the first node. And also we have to indicate null in the last node, that is the right link of last node should be equal to null. Okay, so with this, let us understand what are the operations to be performed. The first we'll go with the insertion operation. So normally when you want to do insertion, first thing is to create a node and dynamically allocate the memory for the node. So temporarily I am considering a node. This is the new node to be inserted at the front location. Yeah, normally we have to create, as of in the previous cases in the singly linked list also, we created a node first. Okay, then assign the data part and the link part. Just I'm considering for an example, I'm considering SSN is equal to 4 for a new employee. We are trying to insert a new employee at the front location. Okay, so when you want to do the insertion, we have to change the link part of the new node and also the first node which is present. Okay, so what happens to the left link of first? So now 4 should be inserted before 1. Hence, what happens? The left link of 1, the left link of 1 will be now pointing to 4, and the right link of 4 will be pointing back to 1 because we have two link parts here. Okay, so this is the insertion. So we have inserted 4 before 1, and what happens to the pointer first? Okay, earlier first was pointing to 1. So after 4 is inserted, what happens to our first? It should now point to 4 because that is our first node. Okay, so this first will be removed here. We don't have first pointed to that particular location. Now first will be pointing to 4 after front insertion. Okay, so this is first. So this is how we have to perform the insertion operation. So we have to change the link, that is left link and also the right link, and also change the first pointer. Then similarly, if I want to do the end insertion, let us understand the end insertion here. Okay, so while doing the end insertion, normally whenever you take any of the cases of insertion, first step is to create the node and assign the memory for it using the malloc function. Now trying to insert 5. 5 is the new employee with the SSN equal to 5. So now I have to insert after 2. So when you want to do insertion after 2, definitely the right link of 2 should be changed. Initially it was equal to null. Now the right link of 2 should be now pointing to 5. And what happens to the left link of 5? So left link of 5 should now point to 2. Okay, so this is a node is added at the end location, that is after 2, and since pi is my last node now, the value at this right location, right link should be now equal to null. Okay, so this is the logic or method we follow for doing the insertion at the front and also insertion at the end. So whether it is front insertion or the rear insertion, first step is to create the new node and also allocate the memory for it. After it is allocated, next step is to change the link parts. Okay, so these links should be changed for the front insertion, and also I have to change the value of this first to point to the new node because it is the front insertion. So while doing the end insertion, the last node link should be changed, and the new node whichever you are trying to insert, that becomes the last node. So this is the example of inserting from the front and also inserting at the end. Similarly, let us check how do we delete from the front and the end location. So as of now, 4 is my first node because you have added 4. Suppose if I want to delete from the front location, so 4 should be deleted. So while deleting 4, what should be done? The link of 1 should be changed. Link of 1 was earlier pointing to 4 and 4 right link was pointing to 1. So this link can be removed just for understanding purpose, and the left link of 1 will be now made as 0 because that is my first node, and also the first pointer, it was earlier pointing to 4, now it should point to 1 because 4 is getting deleted. So after you change all the links and also you change the pointer of first, now your node is free. I can deallocate the memory allocated for this particular variable. Okay, so this memory allocation can be deallocated by using the concept of free. You can directly call the free function. So free will deallocate the memory. Okay, so this is the procedure for doing the deletion from the front, where you'll be changing the link of your node, that is left link of 1 is changed to null and right link of 4 gets changed. After you change the value of this first, okay, when 4 gets deleted, first becomes my starting node. Okay, first will be now pointing to 1. So after you change that, directly I can call the free function for deallocating the memory. Similarly, if you want to do the end deletion, okay, so while doing the end deletion, 5 should be deleted. For doing that, the right link of 2 should be changed, and also this left link of 5 should be changed. Okay, so now there is no link. After that is considered, now we have to change the value of right link of the last node to be equal to 0, okay, or it is considered as null because that is my last node now. So according to the example, now the link is changed and also last node is pointing to, the last node is considered as null. Now I can call this particular free function for deallocating the memory for the variable or memory for the last node. Okay, free can be called here. So this is how you can perform the deletion operation from the front and also from the end location. So only thing is the concept, you should remember the concept properly. After you identify or after you change all the links, then you can directly call the free function for deallocating the memory. So once you understand this concept and also once you know what are the links to be changed and what are the pointers to be changed, then the implementation part will be easy. Okay, so this is the concept of third and fourth method, third and fourth cases operations here. Then we will check for the fifth operation, that is on double-ended queue. So double-ended queue, it is just usage of third and fourth operations. Okay, so double-ended queue, you know already queue contains front, rear, two variables. As of now, I just consider front and rear something like this. Okay, this was the normal queue. But when you consider double-ended queue, also called as DQ, I can use either any of the ends, either front end or the rear end, both for the insertion or and for the deletion operation. So there is no restriction that I have to use only front end or only rear end. I can make use of any of the ends for doing insertion and also for a particular deletion operation. Okay, so this double-ended queue operation demonstration is done by using the method third and fourth. Okay, so and finally the exit case. So this is the concept of double-ended queues and also doubly linked list. Using this concept, let us start implementing that in your C. Okay, so we'll start with normal declaration of your header files. And we need stdlib for memory allocation functions, that is malloc. Okay, so we need these three header files. Afterwards, now we shall declare the structure. So while declaring the structure, now we are declaring it for employee database. So now we have to remember the node structure for employee data. Okay, so the node structure, you know that it has data part and also left link and right link. The data part for employee has 6 fields. Okay, all the 6 fields should be declared here. So first one is SSN. I just define it to be a character type. Then specify name, which is also a character type. Afterwards, they have specified department. Department is also character, indicated as character. And next is designation. Designation like manager or whether he is a project leader, something like that. Designation. Then salary is considered as an integer. Then phone number is again a character of 15. If you want to specify country code, better to take that as a character type. So these are the 6 data members we have defined. Next is to specify the link part, that is left link and the right link. So for doing that, I just use the same structure. It is an example of self-referential structure. So either you can consider this as a left link or also can be defined as previous link. Next is the right link. So right link I just indicate it as next. Okay, so this is the structure declaration. According to the node, we have to define the structure with 6 data and also the link parts. 2 link parts, both are considered as a pointer and they are also self-referential structures. So if it is confusing, instead of previous, you can write it as left link. Instead of next, you can write it as right link. Okay, so once this is defined, now we can define the structure variable. I'll just consider that as employee and node. Node is the structure variable. Okay, memory allocation happens after declaration of the structure variable. So node is our structure which can hold all these things. Okay, so this is the structure declaration. Afterwards, we'll start with the main function. Okay, and they have mentioned that we have to create a menu driven program. Okay, for doing that, we will be using the switch case. Hence, I'll take a variable choice for the switch case, and n is required for total number of employees. Okay, so then we will start with defining the first node. Node is a structure variable. Using that, I'm just using another variable called first. Okay, so first, you already know first is a variable or a pointer which always points to the first node in the linked list. Okay, as of now, since we have not created any node and we have not assigned any data path, initially I'll consider the first value to be equal to null. So why we are making this equal to null? Because still we have not created any node. Okay, hence it is an indication of empty node. When first value is equal to null, it indicates list is still empty. Okay, then usually go with the clear screen operation. So now it is a menu driven program just to display whatever required for the menu option. Okay, it is a program to illustrate doubly linked list. Then use infinite while loop for always displaying the menu cases. Okay, so first operation is creation of doubly linked list for n number of employees. Okay, and also in the question they have mentioned that it is from end insertion method. Hence we have to specify that is end insertion operation. Okay, that is case 1. Then case 2 is to display the status of each of the nodes and also count the total number of nodes present. Hence I just say it as display status and count. Okay, that is the second case. Then going with the third case. So third operation is insertion at the end. Okay, so that is the fourth operation. So normally you can combine the cases, but here since if you want to do insertion multiple times, better to differentiate insertion and deletion at the different cases. Okay, in the question I have mentioned it as a single operation, but you can do insertion at the end or deletion at the end multiple times. Hence, we will give the different cases for each of the insertion and deletion. Now, next fourth operation is deletion at the end. Okay. Then similarly give it for insertion at the front. Insertion at front and deletion at the front. Okay, so then next operation that I have specified is to demonstrate the double-ended queue. So for demonstration of the double-ended queue, we'll go with the case 7. Demonstrate double-ended queue. Okay, so then finally the exit case. So 8th case will be exit. Okay, so after all the choices have been specified, next is to fetch the choice from the user. Okay, so user should enter the choice. So for getting that, use the scanner and person choice. So choice is already defined. So now we will be using switch case and define each of the cases here. So what is case 1? Case 1 is to create the doubly linked list for n number of employees using end insertion. Okay, so here I'll be calling the function called insert end. Okay, this is just a function call and we are passing the address of first node. Okay, so this is a function call. Sorry, one second. So this is the function call. For this, we have to write the function definition. Okay. So in each of the cases, we'll be calling a separate function. As of now, in the main function, let us write all the function calls. Then we will write the function definition. Okay, so next, what is case 2? Case 2 is to display. Okay, so display, and we are passing the address of the first node. Always we have to consider the address of the first node for doing any of the operation, because we have to, that is our starting point. Okay, and third step is to insert at end. Actually, we can combine the first step and the third step, that is case 1 and case 3, because both are inserting at the end operation. Suppose first operation is to create. After creating, if you want to perform end operation, end insertion, so then directly I can go with case 3 rather than going with the case 1 again. Okay, in case 1 we will be specifying the total number of employees, whereas in case 3 it is not specifying any total number of employees, directly it is an insertion. Okay, so in case 2 also it is display is a function call, we have to write the function definition, and end insertion, it is also a function call, we have to perform the, we have to write the function definition for that. And case 4 is to uh, perform the deletion at the end. I'll just call the function delete end, and the input we are passing the address of the first node. Okay, so case 5 is insertion at the front, insert front, and passing the address of the first node. Okay, then case 6 is delete front and pass the address of the first node. So you can look at this main function, it is almost same with the previous programs, and also here it is just calling all the functions. Okay, for all this we have to write the function definition. And case 7 is double-ended queue. I just consider that as DQ, because it is also called as DQ, double-ended queue. And finally, break. Okay, last case is the exit case. You can just write return. Okay, so if you want, you can write the default case also for the wrong option. Otherwise, you can just neglect and stop it at case 7, then close the switch case and while 1 and also the main function. So this is the main function, where every case we have a function call. We have to write the function definitions for each of the function calls here. Okay, so we will start with the first case, that is insert at the end, and also to create the doubly linked list. That is our first operation. Okay, so I'll just write the function definitions before main, so that it avoids function declaration. Okay, we shall start with the insert end operation. So first is insert end. And the return type for this insert end we are considering as node. Node is a structure variable. Why we are considering a structure variable here is, after you create that particular doubly linked list, we are returning the address of the first node. Okay, so that first node address will be of type node, which has the data part and the link part for the particular node. Since you are passing the address of the node, the return type of this should be considered as a structure type. Okay, so structure, as we already defined, a node should hold all these things. Okay, since that address is passed, we are considering that to be equal to node star. It is considered as also a function pointer. And what is the input parameter? You can see here we are passing the address of the first node. Hence, there should be an argument, input argument, and that is of also a structure type, node star first, because we are passing the address of the first node. It should also be a structure type. Okay. So now there should be some declarations here for fetching the n number of employees, and for each employees I should read all the data elements. Okay, for that I'll consider the value of n for total number of employees, and I is required for the for loop, because it should be repeated for each number of employees. Then declare the temporary variables, that is temp and PTR. Let us understand why these two are required. Okay, first temp is required for creating a temporary variable, that is the new node, whereas PTR is required for identifying the last node because it is an end in session. Okay, let us understand that. So in the printf statement, it is only for the display. Enter the number of employees. Okay, get the value of n via scanf. Then, as we know, we have to get the value for each of the employees. So, hence we need a loop here. So, I will be starting with 0 until the last employee, that is, until I is less than n, I will be continuing this process. Okay, what is the first step for doing the insertion? Before doing the insertion, I have to create the node and allocate the memory for it. So now we are creating the temporary node and allocating the memory for it via the malloc operation. Okay, so malloc and specify the size of node. Okay, so node is a structure variable. Since malloc, we have to typecast that to structure type. Okay, by default it will be void, hence we have to just typecast it externally by considering that to be a structure type. So now memory is allocated for it. So after memory is allocated, now you have to fetch the values. That's the data part for each of the fields in the node. Okay, what are the fields we have? We have 6 data part for an employee database. We have to read the values for each of the data. Okay, enter the details of employee. Okay, I just indicate it as percentage %d for specifying which employee you are trying to read. Okay, I'll just specify that as I plus 1. Why we are giving I plus 1? Because I is starting with 0. So here what will be displayed? It is only for the display purpose. Enter the details of employee 1. Suppose if I specify it as I, it will be displayed as enter the details of employee 0. Okay. So rather than displaying that as employee 0, we just want to display that as employee 1. Hence we are considering that as I plus 1. Okay. So now fetch all the data part. What is my first data part? It is SSN. SSN is declared as the character array, hence I'll consider that as percentage %yes. Afterwards, for temporary node, you are assigning the data part. Hence, just use temp along with the arrow operator to fetch it from your structure. Okay, since it is a structure to pointer, we will be considering this dereference or arrow operator. Otherwise, you are using dot operator. Okay, arrow operator and fetch SSN. Similarly, fetch all other data elements. Next is name. Then after name, it is department, temp of department. Then percentages, temp of designation, scanner, and here it is percentage %d for salary. Okay, so when it is an integer, I have to consider ampersand. Why we are not specifying ampersand for strings? Or so whenever you specify array or that is a character array, it will hold the address, starting address of that particular array. In such case, no need to consider ampersand here, ampersand for character type, or it is character array. But if it is an integer, we have to specify that as ampersand. Ampersand should be specified. Okay, it is already discussed in the basic classes also. Okay, so this is about the salary. Next is to fetch the phone number. Phone number is also considered as character array. No need of ampersand if it is string. Okay, then phone number. So this is the elements to be fetched by the user. User should enter all these values, that is 6 data members. After data is specified, we have to consider the link part. Okay. Initially, we will assign both the links to be equal to null because still we have not done insertion. Okay. So the left link and also the right link will be initialized to null for the temporary node. So in this case, we have just considered total number of employees. After that, we are allocating the memory for the temporary node. That is the new node we are trying to insert. For that new node, we have to fetch all the data part, and we have initialized left link and the right link to none. Okay. So next is we will continue for doing the end insertion operation. So what is the logic for doing the end insertion? Logic is I have to identify the last node. Okay, we will start from the first location because we know the address of the first node. Okay, we will start from the first node and we will search for the last node. How do I identify the last node? By identifying the right link to be equal to null. When the right link of any node is equal to null, we can say that it is the last node. Okay. Suppose if the list is empty, still it is a beginning. We are in the beginning stage where we have not created any node. Still the value of first is equal to null. Suppose if the value of first is equal to null, it is a case where list is empty. Okay, when the list is empty, whatever the node you are trying to create, okay, the temporary node, whichever you have created, that itself becomes your first node because there are no nodes available now. Okay, when list is empty, your temporary node itself becomes first node. In that case, I'll just assign the value of first is equal to 10. Earlier, first was equal to null, indicating that it is empty. Now, the temporary node itself becomes my first node. Okay, that is the concept if the list is empty. One second. Okay, then we can directly continue. So continue will continue fetch the other values depending on the value of n. It is for n employees, so it will just continue the next execution. Suppose if first is not equal to null. So when first is not equal to null, it indicates that there are few values present in the list or there are some nodes already available. Okay. In that case, I have to search for the last node. For doing that, we are using a temporary variable called PTR and assigning the address of the first node. Okay. So why we have to assign the address of the first node? Because I will start from the first node and I will search till I reach the last node because we are doing end insertion operation. Okay, hence PTR is initially assigned to the address of first node. Then I have to do the repetition until I reach the last node. I have to just move for the next nodes. Okay, how do I move to the next node? By the right link part. Okay, right link is indicated as null next variable in this program, hence I'll consider that as PTR of next. Suppose if it is not equal to null, indicates that it is still we are not reaching the end. Okay, so when it is not equal to null, what I have to do? I have to just move for the next node. Okay, how do I move to the next node? By its right link part. Okay, so this is a while loop where you will be doing this repetition until you reach the last node. So when you reach the last node, what happens to the right link of last node? It becomes equal to null. You will come out of the particular while loop. Okay, so this 3 lines, it is very simple. So these 3 lines indicates your PTR will start from the first node and it will search for the last node. When it is searching for the last node, if the PTR of next, that is PTR of right link becomes equal to null, it indicates it has reached last node. Okay, after it has reached last node, then we have to come out of the while loop and do the modification of link. Okay, so let us consider the example. Suppose consider you already have some values like I just indicate in the comment lines. Okay, suppose we already have values like 10, 20, and 30. Since it is an end insertion, consider 30 is my last node. I have to insert a temporary node which I have created called 40 to the end location. Okay, after identifying the last node, that is 30 is my last node, to the right of 30 I need to insert 40. Okay, so what are the links to be changed here? The link of the right link of 30 was earlier equal to null because it is the last node. Now, since you are appending uh, 40 after 30, what happens to the right link of 30? It should now point to 40. Okay, and also what happens to the left link of 40? The left link of 40 should point to 30. Okay, so these two link parts should be changed. Okay, we are doing that operation here. Okay, we are just changing the two link parts. So how it is done? What happens to the 10 previous? Here consider it is 10. 10 previous should point to 30. Where do I get 30? 30 is already identified by PTR. PTR will hold the address of the last node because in while using while loop we have found out what is the location of the last node. Okay, so now previous is equal to PTR. Okay, so here you have changed this value. 40 left link is now pointing to 30 and also I have to change the right link of 30. Okay, so where do I get 30? 30 is present in PTR. So PTR right link that is next is equal to your new node. Where do I get new node? It is by temporary pointer. Okay, so only thing is here the operation is very simple. Find out the last node and change the link parts. Okay, previously 30 was last node, its right link should now point to 40. Okay, so that is done here. And what happens to the left link of 40 should now point to 30. That is done in this step. Okay, so only these four lines are very important here. Rest all it is very easy to understand. Okay, so then after that, that is the end of this particular function. Then close this thing and also return the address of the first node. Okay, so this is the operation of end insertion. So while doing the end insertion and also while doing the operation of creation, okay, as we are creating the node here, what happens? I have to specify all this temporary node to be created and also assign the data part and link part. Then the logic part here is very simple. If it is empty, the temporary node itself becomes the first node. If it is not empty, search the last node and change the link of the fields already available. Okay, this is the end insertion concept. Now let us go with the display. Okay, so display also we have an input parameter similarly like previous case, that is the address of the first node which is of type structure. Okay, and then I'll just define the temporary variable called PTR and initialize the count to be equal to 0. Okay, so how the display is done? What is the logic for displaying? So logic here is I have to start displaying from the first node. Start with the first node. You display each data part, okay, and move to the next node. Where do you stop when you reach the last node? After you display the details of all the nodes and also count the total number of nodes, then you can stop at that particular point. Hence, you have a repetition here or some iteration is required. Hence, you can add either while loop or for loop. Okay, just for understanding, I'll just consider the for loop. What is the starting point? So PTR should start from the first location. Okay, that is equal to first until you reach the last node. Okay, when PTR is not equal to null, okay, so PTR is equal. What is the incrementing? Here incrementing is I have to just move for the next node. Okay, so next node, for moving to the next node, you'll be using the right link part. Okay, so this for loop gets repeated until you find the last node. So when you go with the last node, what happens to the right link of PTR? It becomes equal to null. In that case, this condition becomes false. Okay, so then go with count for displaying the total number of employees. So here I need to display the data part of each of the employees because it is the displaying operation. Okay, so displays the status. Percentage D is only for displaying for which employee you are trying to display. Okay, slash n. So what is the first data? It is your SSN and it is a character type, percentage yes, slash n slash t for some space, then name, next is name, it is also a character type, slash n slash t, then department, it is also character type. After department, next is designation, it is also a character type. So we had SSN, name, department, designation. Afterwards, we have salary. Salary is integer, specify that as percentage D. Then phone number is also a character type. Okay, so we completed all the data part. Okay, so first is I need to display for which employee you are trying to display all the details. Okay, that will be beginning with the count because you can see here we are just incrementing the count. So how it will be displayed? Employee 1 because initially count will be incremented to 1 from 0. Okay, so that is count and display all the data, that is PTR of SSN. We had to use arrow mark for fetching the details. PTR of name, PTR of department, PTR of one second, PTR of designation, then PTR salary, PTR of phone number. Okay, so that is the end of the for loop. Then you have to display the total number of employees. Okay, or total number of nodes will give you that. Total number of employees are percentage D count. Okay, count will give you the total number of employees. So what is the difference with the count we are displaying in this statement is it will just display it as employee 1 details, employee 2 details like that. After for loop is ended, then you will get the exact count, total count you will be getting after for loop. So that is the end of the display function. So here you will start from the first node and also till you reach the last node, you increment the count and also display each employee details. Once all the data has been displayed, come out of the for loop and display the total count. That is the display operation. So next is we'll go with the insert at the front operation. So the return type and the input argument is same as the insert end operation, that is node star, and also the input argument is the address of the first node. Okay, so here also while doing a front insertion, normally while doing any insertion operation you have to create the temporary node and allocate the memory for it. After you allocate the memory, then go with assigning the data part and the link part. Okay, so it is same as the previous insertion. Okay, so here you can see I'll just indicate all the values. This is completely same. Okay, I'll just copy the same thing here and okay. So here you may not require this line because we are not displaying. We are just we are just creating the node. and also assigning the data part. Okay, so this step is almost similar to your insertion at the end, because any insertion should have a temporary node created, and afterwards there should be a value, that is data part and link part, assign the values. Okay, so after you assign the value for it, next is if the list is empty, whether it is front insertion or end insertion, if the list is empty, the temporary node whichever you are creating, that itself becomes your first node. Okay, hence we should have a condition if first is equal to null. Okay, so this is an example of list, one second, list empty. Okay, in that case what I have to return temp. So this temp will be returned to main function, and it will be assigned to first in the main function. See here, first. It will be assigned to first. Okay, suppose if the first value is not equal to null, in that case it indicates there are some nodes already available. Consider you are doing a front insertion. Consider you already have a values like 10, 20. Okay, now there is a temporary node. Okay, there is a temporary node called 5. We are trying to insert that 5 to 5 before 10. Okay, so what is the value of first? First was pointing to 10. What are the links to be changed? Okay, as you understood the concept earlier also, while doing the front insertion, the first node was earlier 10. Okay, its left link should point to the new node, that is 5. Okay, what happens to the right link of 5? Right link of 5 should now point to 10, because 5 is getting added before 10. So using this concept, let us change the link path. Okay, so first, earlier I'll just consider first. What is first? First is 10. 10. Okay, I'm considering 10. Its left link should be changed. Okay, 10 previous link should now point to the temporary node which you have created, that is equal to 10. Okay, so we changed the left link of 10. What is the remaining part? I have to change the right link of 5. Okay, so that is 5 is temp, its right link. Right link indicates it is equal to next. It should now point to the earlier first value. Okay, earlier first value was equal to 10, hence I will consider that to be equal to first. Okay, finally you will just return the temp, because temp is my first node. Okay, that is the end of inserting at the front. Okay, the concept here looks very lengthy, but it is not so. If you understand the concept, it is very easy. Okay, so just create the temporary node and assign the data part and link part. Then check whether list is empty. If list is empty, the temporary node itself will become the first node. If the list is not empty, then you have to change. The important logic here is these two lines. Okay, so the new node right link should be pointing to the first node from the previous list, and the first node previous link should now point to the temporary node. So that is the concept we have done here. Okay, this is the front insertion. Now we will go with the deletion. So we are done with inserting at the end and also inserting at the front. Now similarly we will go with the delete. Okay, delete front. The input is same and also the return type is same with the previous functions. Okay, so here while doing the deletion, first you need to check whether the list is empty. If the list is empty, I cannot perform the deletion. So how do I know whether list is empty? If the value of first is equal to null. Okay, so when it is equal to null, I can directly print a statement, printf list empty. Okay, no records to delete. You cannot do the deletion. Then you just return null. Okay, this null will be returned to the main function where value of first is assigned to null. Okay, so this is a situation. While doing the deletion, you have a situation when list is empty. Okay, after that, you may also have a situation where you'll be having a single node available. Okay, let us consider that example. If single node is available, I'll just give the example. Okay, this is the case if first of next or the first right link, suppose if that is equal to null, so this is a situation where you have a single node available. Okay, I'll give you an example. Suppose consider you are having only one node called 10. When it is having, what happens? First will be pointing to 10. Okay. So what is its right link? When you have a single node, definitely you know that that is the last node. Okay. Single node itself is the last node and its right link will be equal to null. Okay, it's right link, that is 10 next will be equal to null. So that is the condition we are adding here. If the first node, suppose if you are having a single node and it is first is pointing to that, what happens to its right link? Always if you have a single node, its right link will be equal to null. Okay, so this is a situation when you have a single node. If the right link is equal to null, so indicates that there is a single node available. In that case, that 10 should be deleted because that is the only node available. So that will be deleted. After it is deleted, after 10 is deleted, what happens? The value of first, it should be equal to null. Okay, because 10 delete, when 10 is deleted, the first should be equal to null, indicates that list is empty. Okay, one single node is deleted, the list will become empty. So to differentiate that, what we are returning here, we are returning null. Okay, where it is returning, it will be returned to the function. Okay, here it will be returned. First becomes equal to null in that case because we are sending null. When first is equal to null, list becomes empty. Okay, so single node was available, that single node was deleted, hence first value will be now equal to null. That is the case. Okay, so we had two situations. One is list empty, another one is availability of the single node. Suppose if there is no single node, if you have multiple nodes, okay, in such case, how do we delete? So it is a deletion from the front operation, that is first node should be deleted. In that case, you have different kind of implementation. One is you can use free, that is memory allocation function. Deallocation function can be used for deallocating the memory, or you can also use this method which you are following now. I'm just returning the address of first of next. Okay, we shall understand this with an example. Consider the value of first is equal to 10. After 10, we have 20. Okay, consider we have two nodes already available. This is a situation where you have more than one node. Okay, suppose when you have example like two nodes 10 and 20, first is pointing to 10. Okay, since it is a front insertion, which node should be deleted? 10 should be deleted. Okay, after 10 is deleted, what happens to my node? 20 becomes my first node. Okay, so earlier it was 10. How do I fetch 20? I can fetch 20 by the right link of 10. Okay, that is first right link will be pointing to 10 because this is a link which is created. Okay, we have this link from 10, we have a link to 20. So once 10 gets deleted, my node 20 becomes first node. Okay, I'm just deleting 10, so 20 becomes my first node. So in that situation, the right link should be returned to your first variable. Hence, what we are returning here, instead of calling the function free for deallocating the memory, so that was one way of deleting. This is another way of deleting where you are just passing the address of the next node. Okay, first node gets deleted, just pass the address of the next node. So this address will be returned back to your first. Okay, now what happens? First will be now pointing to 20. First points to 20 because you are passing the address of 20. So this is another way of performing the deletion where free is not used. Okay, so this may be simple because we are just returning the address of the next node, whereas address of first node will be retained as it is. Suppose if you want to delete or deallocate the memory directly, you can call the free function. Okay, so we have three situations in deletion operation. First is emptiness. You cannot delete. Suppose you have a single node, delete that node and return null to the first node. If you have more than one node, then delete the first node and pass the address of the next node. Okay, so that is the operation of delete front. Now we will go with the delete end operation. Okay, return type and the function input parameter both are same from the previous cases. Okay, node address of the first node. Okay, then we'll define the temporary variables temp. Sorry, I'll not consider temp, ptr and last. Okay. So here also we need to check whether the first is equal to null. If first is equal to null, it indicates list is empty. It is same as the previous case. We cannot perform the deletion operation. List empty, no records to delete. Okay. Then you return the null value. Return null. Okay, so this is a situation, and also we need to check whether we have a single node. Okay, this is same as the previous case. If first of next is also equal to null, indicating that it is the availability of single node. When single node is available, that gets deleted and you return null to the first node. Okay, when single node is available, after it is deleted, definitely the list is empty. Okay, this is another situation. And third situation in deletion is if you have more than two nodes. So if more than two nodes are available, when you are trying to delete at the end, what is the logic to be applied? I need to identify the last node. Okay, for identifying the last node, so already we have done it in the insertion at the end. How do I identify the last node? I will start from the first node until I reach the last node. I will repeat. Okay, this is the procedure we have done in the done in finding the last node. So same implementation is also applied here. Okay, so PTR is initially assigned to first because I have to start from the first node. Then I need to just move for the next nodes. Okay, how do I move to the next node? By the right link of each of the nodes. Suppose if it is not equal to null, okay, while will be repeated. In that case, last is assigned to PTR. PTR value will be assigned to last. Okay, and we have to move to the next node by its right link. Okay, so this is the addition I have added here compared to the insertion function. Let us understand what happens here. Okay, so here PTR value, this last will hold the address of the previous node from the last node. Okay, let us understand that with an example. Consider you have some values like 10, 20 and 30. Okay, so when we apply this, initially it will start from the first value. Okay, that is equal to 10. Afterwards, while loop gets repeated until I find the last node. What is my last node? Last node is equal to 30. Okay, so this value of last, variable last, will be pointing to the last variable or will be pointing to the node which is just before the last node. Okay, and what happens to your PTR? PTR will be now point to your last node. So why we are saving the value of the node just before the last node is when I free the memory location for this PTR, 20 becomes my last node because you are deleting 30. When 30 is deleted, I just want to know what is my last node after deletion. 20 is my last node, hence you are just retaining that value. So why two variables are required here is I am using the free function, that is deallocation function, for deallocating the memory. I cannot use the single variable. I cannot just free the PTR. Okay, without having the last, I cannot free the PTR, hence you can go with two variables. One is to identify the last node, and another one is after deallocation of the particular last node, I need to identify what is the new last node. Okay, that is where you will commit the two variables, last and PTR. So now PTR will be deallocated. Okay, PTR memory gets deallocated. So when PTR memory gets deallocated, that will be not present in the link. Okay, in the linked list it gets deleted. And now earlier 20 link was pointing to 30. Right link was pointing to 30. Now this link should be removed because 20 will be the last link. Okay, when 20 is last node, what should be done? The right link of 20 should be equal to null. Okay, its right link is equal to null. So this link should be added. That link, that implementation, I will just add it here. Okay, so last is 20. Its right link should now be equal to null because that is my last node. Okay, finally just return the address of the first node. Okay, so this is the concept of end insertion. First is if it is null, list is empty, don't delete any nodes, it is not possible. If you have single node, delete that node itself and return null to the first because when list then list becomes empty. So if it is not single node, then if you have multiple nodes, search for the last node via your variable or via the link of each of the nodes, that is the right link. When you reach the last node, just identify the node which is just before the last node. Okay, then free the memory of the last node, that is PTR, and assign the right link of its new last node to equal to null. What is my new node? According to our example, 20 is the new last node and its right link is equal to null. Earlier it was pointing to 30. Okay, so this is the example of deletion at the end. Now we will go with the double-ended queue operation. Okay, so double-ended queue, there is nothing new here. We are just calling the same functions we have already implemented. Okay, initially I'll just consider the first value equal to null. Okay, empty condition. Then go with the choice because we have different cases like insertion and deletion can be performed at any of the ends. Okay, all these things should be demonstrated here. For that, use the display menu options, demonstration of double-ended queue. Okay, so while one, then give the menu options here. Okay, so we have four options, that is insertion, deletion from the front and insertion, deletion from the end. First I give insert front, then specify delete front, then third is insert at the end, no need of slashing, it will create lot of spaces. So fourth is, sorry, it is delete end, then you also display. So fifth operation we will just take it as display, and finally the exit key. Okay, then get the choice and person choice. Now specify switch case. So for each of the cases, just call the functions. Okay. So what is the first operation? First operation is to perform insert front. Okay, I'll just call the function. So already we have written the function definition for each of the function calls. We are just demonstrating that for the double-ended queue operation. Okay, so if choice is this double-ended queue choice is selected, directly they can apply the directly they can use any of the methods. Okay, so second is delete front. Okay, and come out from the particular case. Then third operation is insert at the end. Then case 4 is delete at the end. So for all this we have to pass the address of the first node. Then case 5 is to display. Just we are calling the same display function which we have already written the function definition. Then case 6 is just an exit case. Just return the. Okay, so this is the end of the switch case while one and while one and then the end of the double-ended queue function. Okay, so here it is the simple function where we are just demonstrating by calling the same functions again. Okay, that is the end of the particular program. Okay, so we have written function definitions for all the operations which we have performed in each of the cases of the main. Okay, so now let us execute the program. Okay, I just give the name as dll2.c. Okay. Okay, so it is not an assignment. You have to check whether it is equal or not. Okay, then compile the program. There are no errors in the warnings. Just run the program. Okay, so this is the program to illustrate your doubly linked list. Okay, I'll give choice 1. So it will ask you for the total number of employees. Just for an example, I'll give 1. Okay, so enter the details of first employee. Okay, so for first employee, we need to enter 6 details. First one is SSN, that is Social Security number. I'll just give some random value. Name, you can specify name randomly, and department is CSC. Designation is manager, and salary, give some random salary, and the phone number. Okay, so we have inserted single employee details. Let us check whether it is inserted with the display operation. I'll give choice 2. Okay, it is displayed. Okay, employee 1 and SSN, name, department, everything is displayed, and also it is displaying total number of employees or 1. Okay, so actually you need to give /n. It is not 11. Actually, next menu is also getting appended to that particular line. Okay, we can give /n in that particular case. I'll just go over the case 3. Okay, it is inserted at the end. It will ask you for the number of employees. I'll give 1. Okay, for that we need to enter the employee details. Some random value for SSN, name, department, designation, salary, and phone number. Okay, so I give display Okay, so you can see it is an insertion at the end. Since it is insertion at the end, so Smith was the second last inserted employee that is added after John. Okay, and also it is displaying the total number of employees which is equal to 2. Okay, then again go with the insert front operation. I'll give a file insert front. It will ask you for 1 second. Maybe we have specified differently. Okay, 1 second, we will check. For choice 5, it was not taking properly. We shall check what was the problem. Case 5, right? Okay. So case 5 is insert first front. Okay, while doing insert front, okay, maybe I can specify the printf statement here for enter the, because it is not displaying anything. Okay, for front insertion we can add it here. And also while displaying the total number of employees, it was not considering the space, right? I can specify the space. Okay. Sorry, it is not saved. Okay, it is equal. Now I have saved. You can compile. Okay, and then we can execute. Okay, immediately I will be going for the choice 1. Number of employees is 1. And enter the details. First is specify the SSN, then name, and you can go with the department, designation, salary, and phone number. Okay, so one of the employee details is entered. Afterwards, I'll go with display. So it is displaying properly. Then I can go with choice 5. It will ask you for total number of employees. Okay, now enter the details. SSN I have by miss SSN I have given it as 1. Then I'll give name Smith. Okay. Department is CCE. Designation is manager, and we had salary. After salary, it is phone number. Okay, so it is added. I'll give display. Actually, it is front insertion. Since it is front insertion, you can see Smith is getting added at the first location, and also it is displaying the total number of employees correctly. Okay, so total number of employees are equal to 2. Okay, so afterwards we'll check with the so first case is properly working, so second case is also working. Let us check with the third case, that is insertion at the end. Okay, enter the number of employees. I have given 1. Then specify the SSN. I'll give SSN is equal to 2. Then specify some random name. Okay, name of the employee. After name, it is department. After department, it is uh, designation. I'll give some technician. Then specify the phone number. Okay, so now there are 3 employee details. So the previous employee which was added, it was end insertion. See, the last employee it was added is added. It was considered at the end. Okay, so now go with the deletion. Deletion at the end. So end is deleted. Let us see whether it is displayed. So you can see the last employee is deleted. Similarly, you check with front deletion, that is 6. Okay, so 6 is front employee should be deleted. So Smith was deleted. Now the remaining is we have only John. Okay, then we will go with the another deletion, that is 6. Okay, there is only one employee that is already deleted. Now the list is empty. Total number of employees are equal to 0. Okay, so now all the cases are done. Next we have to go with the case 7. Okay, case 7 is the demonstration of double-ended queue. I'll go with just a simple example. Choice 1, number of employees is 1 I am considering initially. Just give the employee details with SSN, name, department, designation, salary, and phone number. Okay, so this is added. If you want to display, give choice 5. So the total number of employees are 1. Similarly, go with the deletion. If I give choice 2, there is only one employee that is deleted. Give choice 5, total number of employees are 0. Okay, so again, if you want to do end insertion, give choice 3. Enter the total number of employees. Specify the details, name, SSN, department, designation, salary, and phone number. Okay, so this is added. Display, give the display. Okay, it is displaying the fifth. It is displaying the number of employee details, and check with the deletion at the end. I'll give 4. It is getting deleted. Okay, after it is deleted, display total number of employees are 0. Then you can give 6. It will come out of the particular menu and it will show the main menu. Okay, so once it shows the main menu, then I can directly give choice 8 for coming out of the program. Okay, so this I have shown example for only one of the employee details. Similarly, you can check for adding 2 more employees and check whether it is working properly or not. Okay, so this is about the program doubly linked list where we have implemented different operations for the employee details. Okay, similarly check for all the possibilities whether deletion and insertion is working if there are more than one employees. Okay, so thank you everyone.